Let's start with what the Turing test actually tries to measure. The idea is simple. If a machine can hold a text conversation so well that a human judge can't tell it's a machine, then the machine is said to pass. In an interview, a good way to explain this is to say that the test checks whether an AI can imitate natural human conversation. That answer works because it shows you understand the test as a behavior check, not a deep intelligence check. You can think of it like playing a guessing game over text messages. If you can't tell which friend is a bot, the bot wins. Interviewers might ask why Turing used text only, and you can say that removing voice and appearance keeps the focus on reasoning and language. They may also ask whether passing proves real intelligence, and you can explain that it only shows imitation, not true understanding. This sets the foundation for the rest of the conversation. Now let's look at how the test evolved. It starts in 1950 with Turing's imitation game and moves through early chatbots like Eliza, attempts like Eugene Dostman, and today's large language models that blur the line even more. When interviewers ask how it works, you can say that the judge chats with both a human and a machine without knowing who is who, and tries to tell them apart. That's a strong answer because it shows you grasp the structure of the test. A helpful way to picture it is a blind conversation where identity is hidden and only language reveals clues. Interviewers might go deeper and ask why this approach mattered at the time. He can explain that computing was new, so focusing on text made evaluation simple. They might also ask whether modern models pass it, and you can say many do in short conversations, but still lack deeper comprehension. Let's talk about where the Turing test falls short. It focuses only on language output, so a system can sound smart without real reasoning. In an interview, a good way to frame this is to say that the test measures performance, not understanding. That matters because modern models can mimic patterns without truly thinking. You can use a simple example. A chatbot might sound empathetic, but have no real grasp of emotion. Interviewers may explore whether the test can be tricked, and you can say yes. Clever scripts can exploit human assumptions. They may also ask whether the test ignores the physical world, and you can explain that it says nothing about perception, action, or interaction. These points show that you understand both the value and the limits of the original idea. Because of those limits, modern evaluation frameworks step in. Benchmark datasets like GLUE and MLU score models on reasoning, comprehension, and consistency. Embodied AI tests focus on physical interaction, showing how an agent handles movement, objects, and spatial reasoning. A strong interview answer here is that today, we judge AI with specialized tests that measure specific skills, not broad imitation. That answer works well because it reflects how the industry builds and evaluates systems. You can picture benchmarks as a report card, where each dataset measures one skill. Interviewers may also ask why we need embodied tests, and you can say that real-world systems must sense, decide, and act, which conversation alone cannot capture. As AI grows, newer methods look beyond simple text imitation. The Winograd Schema Challenge checks whether a model understands context by resolving ambiguous sentences. The Total Turing Test expands evaluation to vision and robotics, measuring perception and physical interaction. And AI safety benchmarks check alignment, truthfulness, and risk. In an interview, you can summarize this by saying, modern evaluation focuses on reasoning, perception, and safe behavior. That's a strong answer because it shows awareness of current industry concerns. Well, interviewers might ask why common sense reasoning is hard for AI, and you can explain that models often rely on patterns rather than true understanding. They may also ask why safety benchmarks matter, and you can say they help prevent harmful outputs in real-world deployments. Interviewers often explore deeper ideas around the Turing test. They may ask why the test is seen as flawed, and you can explain that it rewards deception rather than true intelligence and doesn't check reasoning. They may bring up the Chinese room argument, which says a machine can follow rules without understanding meaning. You can summarize it as the idea that symbol manipulation is not the same as comprehension. Finally, they may ask how today's large language models relate to the test. A good way to answer is to say that many models can pass short-form conversations, but passing doesn't prove self-awareness or deep understanding. Keeping your answers grounded like this shows maturity in your thinking. Technical interviews often shift from the Turing test itself to modern evaluation. If they ask what benchmarks industry uses today, you can explain that each task has its own metrics, like accuracy, F1, BLEU, or perplexity. This shows you know how models are judged in practice. Another question is whether consciousness is needed to pass the Turing test, and you can explain that passing only shows behavioral similarity, not awareness. Oh. Interviewers may also want real-world context, and you can say that production systems focus on measurable performance and reliability, not philosophical intelligence. This helps them see that you understand both the science and the practical side of machine learning. Great job learning today. If this helped you feel clearer or more confident for your AI or ML interviews, tap like so more learners can find you. If you want simple guidance for every interview topic, subscribe so you never miss the next lesson. You can share your questions in the comments. I read them, and they help me choose what to teach next. And if you know someone preparing for interviews, feel free to share this with them. Keep going. You're improving with every step. I'm here to help you grow.